Need my calculator. In a minute. All right, Grandma wants to give you $50,000 for college when you turn 18. Yeah. How much would she have needed to invest when you were born if she's getting 8% interest compounded quarterly? So now this has to be that compound interest formula. A equals P 1 plus R over N to the NT. Okay, so once you see this compounded quarterly, okay, if it's compounded yearly, that's N is 1, and then that simplifies to A equals P times 1 plus R to the T power. But in this case, since we got quarterly, N equals 4, we got to use this one. All right, we're going backwards in the sense that they're giving you the final amount. So 50,000 has to go here. P is what we're looking for. 1 plus 0.08 divided by 4 to the 4. And then what's going to be the time? 18? 4 times 18. And so I get 50,000 equals P 1 plus 0.08 divided by 4 to the 72 power, right? One thing you don't want to do is you don't want to round off. So you got to be careful on that. And you're just going to keep that whole thing in there. Even if you do 1 plus 0.08 divided by 4, okay, that, all right, that worked out to be nice, to the 72nd power. That's not, you can't round it off to 4.16, okay, or anything like that. You got to keep it exact. So you either take 50,000 divided by the answer, or you can just type the whole thing in at one time. So what is 50,000 divided by the answer? Okay, it looks like I get $12,015.94. Well, obviously, she's not going to input that exactly. She's probably put in 12,000 for that. Or you can divide, okay, 1 plus 0.08 over 4 to the 72nd power. 1 plus 0.08 over 4 to the 72nd power. Okay, you can do that as well. So I can do 50,000. Let me move it over here. Divided by 1 plus 0.08 divided by 4 to the 72nd power. Yeah, I get the same thing. All right, so however you input it, that's fine. Be careful you don't round off. 12,015.94. So P equals 12,015.94. So going backwards, so if you want to know how much you're going to need in 15, 20, 25 years, all right, what do I need to start with? And you kind of work from there. So now that might have affected 79 and 80 because those were working backwards. So check your answers there. I want to talk about 32 here in a second, but check your other answers as well. And for 56, and those others also asked for your horizontal asymptote. It also asked for domain and range. So I got those listed as well as the graph. So domain, negative infinity to infinity. You can plug in any value to an exponential function. You're never going to get undefined because you're not divided by 0. You don't have a square root. Range, negative infinity to negative 2, based upon how it's been shifted. Horizontal asymptote. Y equals negative 2. As x goes to negative infinity, okay, f of x will go to negative 2. Okay, it's going to flatten out to that negative 2 value. All right, 76. Okay, now I think for part B it says what was the interest. All you had to do is take that amount from A and subtract your initial amount and figure out the interest. Okay, for that one. 80 should be 4,528.90. I believe that was the one where they give you the A value, you had to find the P. So that was similar to what we just did with the college tuition one. And in 98, I got $18,629.40. All right, check your answers. I'm going to do 32. After I do that, let's see if there's anything else that you need to do from there. A lot of you did 32, but you didn't correct. Well, you didn't write the final answer. This is the answer that they want. It'd be 3 times 2 to the x. There's 2 pieces to that one. There was an A and a B. So for 32, Ryan, what are the 2 points they give me for A?
0, 3, and 212.
0, 3, and 212. And they want to write it in f of x equals, which one is the A? Let me see here. C times A to the x. So take this, plug in 0, 3. 3 goes in for f of x. We don't know C, we don't know A, but x is 0. A to the 0 is 1. So 3 equals C. Now, that replaces the C, so it becomes 3 times A to the x. Take your second point, 212. 12 goes in for the y, equals 3 times A to the second power, because x is 2. Divide by 3, and I get 4 equals A squared, A equals 2, and now make sure we write that final answer, 3 times 2 to the x. B is similar to that, but you end up with 5 times 3 to the x. They just have 2 different points. One of them has a 0 in it. Always plug in that point with the 0 first. Okay. All right, anything else? Carlos, you good? Questions?
No, I'm good.
All right, sure?
Yep.
All right. And Josh, anything? Okay, anybody? All righty. Let's keep going on those notes. Now we're going to talk about the number E, which everybody knows what that is, I'm sure, at some point. And then we're going to continue with this compound interest formula. All right, we said you can compound. There's no limit to what you can do with compounding. So, if you want to compound quarterly, you do it 4 times a year. You want to compound monthly, you do it 12 times a year. You want to compound every day, you do it 365 times. And every time you compound, it increases just a little bit each time. Okay? But it's not an infinite increase. It doesn't go to infinity. All right, an easy way to look at this is we're just going to take $1 at 100% interest. Okay, so now here's why this is easy to look at, because if you think about A equals P times 1 plus R over N to the NT, and we're going to look at it for 1 year. So if I let $1, so that's going to be my P, 100%. Well, we always write that as a decimal. What's 100% as a decimal? 1. So that's where we get the 1. And then if we're doing it for 1 year, so T is 1, so this just becomes 1 plus 1 over N to the N power. Okay, so that's the value of $1 at 100% interest. But we get 100% interest at the end of a year. Okay, if you compound it 1 time, you should end up with $2 because you're going to double it. If I do it semi-annually, N equals 2, you end up with 2.25. So you get more. If I do it 4 times, I get 2.44141. Now, I know I always talk about rounding it to 2 places, but for this little thing, we need to round it to, let's go to 6 places, even though that one's 5 places should be fine, so we can see the differences. All right, so let's see what we got here. How many we got left? We got 1, 2, 3, 4, 5, 6. We're going to go to every second. All right, this group here. You guys do. All right, you're going to do 2 of them, but you're going to start out with monthly. So I'll put you 1. You guys in the middle are going to do weekly. You guys on the end are going to do daily. You guys are going to then do every hour. You guys are going to do every minute. And then you guys are going to do every second. So you should have 2 to calculate. All right, I'll do the first one just to make sure we're all on the same page. All you're doing for monthly, N equals 12. You're plugging in 1 plus 1 over 12 to the 12th power. So whatever that is. And now you're going to round it to 5 decimal places. 1 plus 1 divided by 12 to the 12th power. 2.61304. 2.61304. All right. See what you come up with. Kind of talk amongst yourselves. You guys should have 2 to do, and we'll share the load. Make sure you at least, if you get down with both of them, you can go back and fill in others, but at least do those 2. Weekly is 52. Daily is 365. And so use that for the rest. So 365 times 24 hours will give you hourly. And then you got to figure out every minute. And you got to figure out every second. All right, now I got every second. Did you get 31 million seconds? So 31,536. So 31,536 seconds. All right, so let's go here. All right, monthly we did 2.61304. 1 plus 1 over 52 to the 52nd power. All right, Colton, what'd you get for that?
I got 2.69259.
All right, make sure we agree. Yeah, okay. So we increase. So we do it every week. We're up to 269. Okay, for that. All right, daily. If we do that one, Nathan, so we get 1 plus 1 over 365 to the 365th power. What'd you get for that, Nathan?
2.71457.
2.71457. We agree? All right, you see your head nod. Hourly, 1 plus 1 over 8,760 to the 8,760 power. Brian, what do we get for that? Uh-oh. Josh, what did you get for that? Hourly.
2.71813.
1.3?
Yeah.
All right. Brooklyn, we agree? Okay. So now, if you noticed, it's leveling off. Monthly was, like if you talk about cents, 261. Weekly was 269. Daily it went up to 271, but now there is a slight increase. It would round to 272, but we still have 71. We went from 714 to 718. All right. So now 525,000. 1 plus 1 over 525,600 to the same power. Ashlyn, what did we get?
2.71828.
So 2.71828 for that one. Now there's an increase, but it's even less, right? And now how about every second? How about every second? Madison, you got something different?
I got that for every second.
Did you? All right, what'd you guys get for every second? Same thing? All right, I think that's right. 2.718 0.28. Now let's take a look real quick. If I put those in, so clear 1 plus 1 divided by 525 600 to the 525 600 2.71828. Now, what do I get here? 1 plus 1 divided by 31,536,000 to the 31,536,000 power. Okay, now it rounds to 5 decimal places, the same thing. Is it exactly the same thing on my calculator? No, it's close, but it goes 2.718279, and this is 282. So it doesn't keep increasing, but ever so slightly. Ever so slightly. Is it going to go to infinity? It is not. It levels off. Okay. Where does it level off at? It levels off at the number E. There's your number E. 2.71828. Now it looks like it repeats. It looks like it repeats, but it doesn't. Not. That's just where it rounded off at the end. Okay. The number E is given by this definition right here. E equals the limit as n goes to infinity of 1 plus 1 over n to the n power. Now, there's no reason, if you do it every second, there's no reason you can't do it every half a second. There's no reason you can't take interest every 1/10 of a second. Okay? You can make that a smaller and smaller interval. So you go basically to infinity. Okay? And we make that, and now it will round off. So if you take a look, so E is approximately 2.7. What do we have up there? 1828. It is like the number pi. It is irrational. It means it never repeats. It never terminates. Okay, and it is named after Leonard Euler. Now Leonard spells his name Euler. Pretty smart guy. What was he? 1700s? Let's check. Pretty smart guy. Did a lot. Allegedly, he is the last person to know everything in terms of all of mathematics. Okay, so every little field of mathematics he was competent in. Now there's so many little subdivisions that there's nobody that knows everything about all of mathematics. But Euler was. So we got all the way to that limit. So this results in what we call continuous compounding. Okay, continuous compounding this is your formula. A equals P times E, which is that number, to the RT power. PERT, if you look at it that way. It used to be I think it's still out there, but it's a shampoo. Okay, PERT plus. So P times E to the RT. P is your initial value, R is your interest rate, T is the time in years. But it must say continuous compounding. It cannot be compounded quarterly or compounded monthly or compounded daily. Then you use your compound interest formula. So if you look at that example on the bottom. Okay. It has to state that it's being compounded continuously. Okay, it has to state that. If it states that, then we can use that little formula. All right, find the amount in an account if $10,000 is invested at 6% for 20 years and the interest is compounded continuously. At this point, we can use our PERT formula. A equals P, principal, times E, Euler's number, to the RT power. And so the amount will equal 10,000 E to the 0.06 times 20. E shows up in two places on your calculator. On the left-hand side, see where it says ln? It'll have e to a power. On the right-hand side above division, it just has e. I don't know why it shows up in two different places. Okay, maybe so there's a lot of time you just use e. We need to take e to a power, so I'm going to do 10,000 times. Now, you don't necessarily need to hit the times button if you write next to it. E to the, and it automatically gives me a parentheses. Yours probably just gives you that little box up there. 0.06 times 20. $33,201.17. Okay, 33. $201.17. This is the best of the best. You can't get better than this. You know, this is going to be better than compounded quarterly, compounded monthly. This is absolutely the most you can get compounded continuously. So 33. Any other type of compounding will have to be smaller than that. Okay. All right, flip it over to that next page. So that is compounded continuously. E is a number. We need to know its graph. We need to know what the graph of e to the x looks like. If I go to my calculator and I go y equals, and I type in e, and I put in e to the x, I hit graph, and I'm going to have to change my window. I'm going to go zoom 6. Okay, it is no different. Well, it's the same. It's an exponential function. It is going to be just like 2 to the x power. We just need to kind of have an idea where some of these points are. I'm just going to do real quick. XY, -2, -1, 0, 1, and 2. Kind of list it, like to the nearest tenth, that's fine. You can use your table and your calculator. You can plug them in, whatever you want to do. But you need to kind of have an idea. E to the -2 is 1 over e squared, which is about 2.718 squared. Well, if you take a look at your table, at -2, I got let's go nearest hundredth is fine. I'll go 0.14. 0.14. And then -1, I got 0.37. 0.37. Anything to the 0 power. Even e is 1. Anything to the 0 power is 1. E to the first power is just e, which is going to be 2.72 if I round it. And what's e squared going to be? 7.39. So think about those points. So -2, 0.14. -1, 0.37. 0, 1. 1 is 2.72 and 2 is 7.39. So that is e to the x power. No different than 2 to the x power. It'll be slightly different in terms of the y values. All right, we have to be able to do transformations with this. So we got 2 of them here. 2 of them. Before we do anything, let's go ahead and graph e to the x on here so that we can use that for our transformations. Okay, we just kind of went over that. -2, 0.14, -1, 0.37, 0, 1, 1, 2.7, and then 2, 7 point, what was that? 39, I'll make it 7.4. 7.4. And I'm going to do it on the other one as well. And so I got 0.14, 0.4, 0, 1, 2.7, and 7.4. Now you just want to take a look according to that graph. Does it move left or right? Where is it reflected? Where is it shifted? Okay, let's take it to our high school RV. Okay, let's look at that. So for that first one, all right, Tim, what's going on with the first one?
Um, it goes right 3, left 3.
We're looking at you're looking at this one, right?
Yeah.
You're looking at -3. Which one did you say was it? What did you finalize that?
Right.
All right, the right is going to be from the x -2 in the numeral. So it's actually going to go right how far?
2.
2. And what's the -3 going to do?
Down 3.
Yep. So it's going to go right 2, down 3. So right 2, down 3. If our horizontal asymptote is moved, you need to draw it in there. Since it moved, it's not going to go towards 0. It will go towards -3. We need to draw that in there. Now move every point, and we're going to approximate because, like I said, everything's to a decimal here. I'm going to make this a red, so I'm going to go right 2, down 3. And I'm going to take this point here, 1, 2.7, go right 2, down 1, 2, 3. Right 2, down 3. Now that'll be at a nice spot there because it was at 0, 1. And then I go right 2, down 3. Whoops, I didn't go down 3. Right 2, down 1, 2, 3. And then right 2, down 3. So there's my graph. That is e to the x -2 -3. I'll just call it y equals. Okay, so I'm just using my transformation. Right 2, down 3. All right, e to the 3 minus x plus 1. Luke, Hirschberger, what's going on with that one? What's the 3 minus x do?
Goes right 3.
I'm going to just not right 3.
Left 3.
Yes, because here's what you want to think about that. So think about that as if I wrote it as -x plus 3. So if it's a plus 3, it moves it left 3. What's the negative do? What do you think, Luke?
Is it flipping over the y-axis?
Flips it over the y-axis. Yep. So it goes over the y-axis. And then what's that last one there? It is plus 1. What's that do?
It goes
Up 1. So now my horizontal asymptote will go up 1. Left 3 over the y-axis, up 1. All right, go ahead, plot those points. I'll plot them here in a second. That's the right. What is going on with that? Was it working at all?
I think.
You guys probably wouldn't even tell me the room was on fire. Disconnected. Maybe we're having Wi-Fi issues. Huh, must not be working. All right, so I'm going to take my points. Let's see here. What do we say? Left 3, 1, 2, 3. Flip over the y-axis, down 1. Okay, and then I go left 3, 1, 2, 3. Flip over the y-axis to 2. And then we want to go up 1. I went down 1. Hey, who noticed yesterday we graphed that first one wrong? Or I graphed it wrong. We did one of them, we graphed it wrong. I was looking at the other classes. Which one was it? Let's see. Oh yeah, it was from the other one. I'm not gonna go back and fix it at this point, but it was, yeah, put that over. Yeah. That first one we graphed it wrong. Okay, well, I forget what we did incorrectly, but you guys are supposed to fix that for me. So let's see here. We said left 3, 1, 2, 3. We'll flip over, up 1. Okay, so that'll go here. Left 3, 1, 2, 3. Flip over, up 1. Left 1, 2, 3. Go to negative positive 3, up 1. Go 1, 2, 3. I'm at negative 4. Flip over to 4. And then 1, 2, 3. That's 5 right there. So it's going to look like that. Okay, for that case. So graph your original function and then use your transformations. You're going to have to do these without your calculator. Okay, without a graphing calculator. So you got to know the base function, be able to graph that. All right, last one. Exponential growth or decay. This is the same formula as the PERT, except we just identify things a little bit differently. And you see there, it says A sub 0 equals e to the kt. Well, k will be a rate of growth or rate of decay, which would be similar to your interest rate. Okay, so it's basically the same format. So anything with exponential growth or decay can be modeled with this case here. So that example that you see, the population of a town has been growing exponentially. You have to be told that. You have to be told it's growing exponentially in order to use that form. Since 2000, if the town had 24,500 residents in 2000, and the annual rate of growth has been 1.25%, determine the population in 2020. So we got A equals A sub 0 e to the kt. Our original population is 24,500. K is 0.0125. Move your decimal place 2 places to the left, decimal point, 2 places to the left. The time is 20 years. Okay, so that is going to be your power. Use your calculator. And then let's see what we get. Ooh, 24,000. Now round it to the nearest person, since we're dealing with population and not money. Nearest whole number is fine. 2,400 e to the power 0.0125 times 20. And I get 31,459. So people, 31,459. All right, if it says it's growing 1.25% per year, that's different. Okay, this is exponentially. All right, 4-1, there's a lot in there. All right, here's the homework. I got over here a quiz. We'll be over 4-1. We're going to quiz over 4-1 and 4-2. It's either going to be Monday or Tuesday, and it just depends on what happens with this late start day, how much we get done with 4-2. Wednesday, Thursday. Okay, so we'll see when we get done with 4-2 tomorrow. How much?